Okay, here we are. So, good morning, everyone. Before we start, let me first introduce myself. My name is Wei Guo, and it's now it's a postdoc researcher with Professor Montanari. So I will delivering the 12 hours of this course. So in general, the part of my courses, we will focus on the practice of how to access the uh, open source data set through the Python. And we will also learn how to download the data from the climate models. And especially, we will focus on the case study of the Strait of Messina to analyze the wind speed of that bridge. And before we start the course, I would like to mention one important thing. Like, I don't know if you have some background knowledge about the Python or coding in general. So if you don't have, if you have, it's better. But if you don't have, don't be afraid of the coding. So nowadays we have many powerful tools, like we can search through Google or through some AI models. We could search the help from ChatGPT or some other models. So don't be afraid of the coding. And it, in general, I think it's it's not a big issue if we make mistakes. When we coding, we always face bugs, but anyway, we will find a way to solve it. So don't be afraid of coding. And in these courses, I will give you detailed documents, and you can follow it by very simple clicks. So, and you can modify the codes based on my codes. So it will be easier. So let's start. Uh, I suggest you to follow the course with your laptops, so you can run my codes when I show the examples. So if you visit the site, uh, but I cannot. Sorry, stop sharing, but I cannot share that. So I'm working on this one. Okay. Sorry, I'm not that familiar with the recording stuff. So if you visit the website of Professor Montanari, you can find the link of the material we will use for this course. It's called this one, Open Source Climate Data, Wind Speed on the Climate Change at the Strait of Messina. So if we click on this link, we will be direct to the Colab. So this is a notebook. It's a Colab notebook. I will introduce what is Colab notebook later. So so you already clicked the links. So here you can see the text we will use in this lecture and also the codes. So here you can see in these cells, we will have the codes. So I already wrote all the example codes. So in the later courses, we will run these codes and you will see how we connect the open source data set and how we calculate the wind speed and how we do some further analysis and draw the beautiful maps, visualize our data. So we will do it later. Let's start with a brief introduction about the open source dataset. I don't know if you have ever tried to download any data about the climate data. or for example, the precipitation, the temperature, or wind speed. So in this lecture, in general, we will visit the climate data store, the CDS. The climate data store is the cornerstone infrastructure which supports the implementation of the Copernic climate change service, and is one of the institutions of the European Center for Mid-Range Weather Forecast. I think you have heard about this institution because they provide the weather forecast for our daily life. For example, if you watch the weather forecast from the social media or from the television, the data source may be from this institution. So they provide the daily weather forecast for some European countries. And they have global weather predictions, not only for the European regions. Their model is a global one. So if you check their forecast, you can find the weather forecast for nearly the global regions, any countries, and also for your home countries. But in your home countries, maybe they didn't directly use the data from this institution, because for your country, for sure, they will have their own institution who provide the weather forecast. But in our lecture, we choose this institution because their data is open access. So it's easier to access by any users. So you only need to register in their website, and then you can download their data and then make your own analysis. So, for example, here in this data store, they provide many variables about the climate. And for example, they provide not only precipitation, temperature, wind speed, they also provide humidity and soil moisture. So any variables you can imagine related to the climate change. And not only for this kind of observation data, they also provide data about the reanalysis dataset. So the reanalysis dataset, we will introduce the concept in detail later. And also they will provide the projections, the future projections from the climate models. So all of these climate data at different temporal and spatial scale. In general, they will not only cover the global one, they also provide some very fine scale regional data set. So you can find in general any data set you want in that website and then download it for your analysis. And so it's very important for researchers and also the stakeholders to make their research or design the adaptation and mitigation strategies for different departments, social sectors, for under the climate change. And here, within this notebook, you can see there are some blue words. So when you click on these words, you will be direct to their official website. So you can have a try, like while you following the lecture, if you are interested in detail what's these institutions or what is these concepts, you can just click the links, or you can click it later on. After the lectures, you will find more detailed description about the institution and in general the data store. And here we will go into the website of the data store we will use in this lecture. So you can click here, the Copernic Climate Data Store, and Okay. But I think now you cannot see my screen of this one. I need to show this one for panics, right? So can you see the web page of the data store, the Copanic data store? Because I'm not sure if the change of the web page. Yeah, so could you give me a response like
Yes, Professor. We are.
so you can see the website. So here you can see the website of the climate change service. Here they provide a lot of things. And when we scroll down this one, you can see the climate data store. It's what we will use to and download our data. So we click this data store. Okay, the cookie will accept all. So here you can see they provide a search and all this kind of stuff. And when we collect, like when we click on the data sets, you will find the data sets here. When we clicks on the data set, you will see a lot of different data sets. So in general, different data sets, they have their own limitation and have their own data sources, and it's suitable for different tasks. So here, for sure, I cannot introduce you all these data sets. It's impossible but here, when you look into the left column, you can see the product type. So when we click here, they will give you an overview, like what types of the dataset we have. So here, for example, we can find that they provide some climate indices, like some index is calculated from some dataset. They are not the raw data directly, they are indices, which represent the, for example, the drought or the flood, this kind of indices. So not the variables, for example, precipitation temperature. And here we also have the climate projections. So it's the data from the climate models, which provide past, present, and also future projections. And here we also have the in-situ observations. So it's the data from the stations, example from the meteorological stations who record the daily precipitation, the daily temperature, and then they upload the observation into this data set. So also here we have reanalysis. So it's the data set merged by the observation and some other data product, or maybe merged from the satellite. So they combine the observation and the satellite or the other source of data set, and then by a data simulation model, so they will have a reanalysis data set. So here you can also find the satellite observation and the seasonal forecast. So here, for example, if we are interested about the reanalysis, so we click here, then they will only show all the data set is reanalysis. So just for just some simple examples. And here, so the providers are all from this Copanic service. And here we can also choose for different sectors. For example, if you are interested about agriculture impact, you can select agriculture. So they will show the data set used for the agriculture. And for example, also biodiversity. So there are some bioclimate indicators. So also if we are interested in energy, they will show us the, let me check. some data set, so energy related variables. So based on your interest. And also here you can see you can select different special coverage. For example, you can choose only the dataset covered Arctic, and also, for example, Europe in general. So the dataset only cover the European region, and also we will have the dataset which cover the global range. So they provide all the variables for the at a global scale. So based on the type of the product, the special coverage, also we have the temporal coverage. You can see here they divided into future. So if you are interested in future, so click on the future. In general, it will provide by some forecast product or from the climate models. So here you can see there's the climate model projections. And if you see in the past, so it will from the reanalysis and also climate models. So all this data set. And here you can also choose the variable domain from different domains. For example, if we are interested in some variables from the atmosphere, for example, the precipitation temperature, we can click the atmosphere. But if you are interested in some variables from land, from our land, we can choose the land. For example, they provide some essential variables from hydrology or from the glaciers, so or the biosphere, bioclimate indicators, you can choose the land. And if you are interested in some variables on the ocean, so you can click here, you can click the ocean. So in general, they will, for example, they provide sea ice or the sea surface temperature or the sea level, seawater level. So when we click in the left column, we can find the dataset we want. And then we can click, for example, here is the Era 5 reanalysis. Is the dataset we will use for our later analysis. Okay, so I think some.
Sorry, Professor, we are not able to see the website that you are scrolling. It is stuck on the slide.
Sorry. Okay. So when you have this kind of problem, just interrupt me. Let me know because I don't know. Okay, let me share. Maybe it's better to share all the screen. Okay, so now you can see all my screen, right? Like even if I click, can you see the website?
Yes, Professor.
Okay. Now it's better. So let me repeat. So from this notebook, we click to visit this website, provide the climate service. And then here is the climate data store, which store all the data set. So we click on this data store and we will find the entrance of the data sets. So here you can see the data sets. So we click on the data sets. And here we are. So we enter the data store and we can find the data set we want. So here is what I mentioned before. Here you can select a different product type. So the different data source from different type of data sets. And it's used for different sectors. So for example, agriculture, energy, health, water management, everything, every different sectors. And also here you can see you can select different spatial coverage from different regions. And also you can select from point data for sure. And also different temporal coverage from past, present to future. And also the variables cover different domains. So you can select the domains you are interested. So for example, I'm from the hydrological stuff, and if I'm interested in the river flow or these variables related to hydrology, I can select the land. So here, after we select, I will give you an example. We will be used to reanalyze the error 5 reanalyze. So we click the reanalyze. Okay, so they will only show the reanalyzed data, and the one we will use is called error 5 hourly data on single level from 1940 to present. So if we click on the dataset, they will enter the detailed description about this dataset. So here you can find what's the name of this dataset and what's the detail about the example here. They provide hourly estimates for a large number of atmospheric, oceanic, and land surface data variables. And also they provide the uncertainty estimate, and also they provide the ensemble mean value from all the models. And they tell us it's update daily. So we will have, so these data sets, they will update daily, and we'll about have a 5 days delay. For example, today is 16th. So we will have data maybe at 11th. So you can check it later in the dataset. So in this page, in general, they give you the description about what inside this dataset. So inside the dataset, in this error 5 dataset, we will have a regular grid for the 0.25. So what does it mean? So it's a grid dataset. So you can imagine they divide the entire Earth surface into different squares. So 0.5, 0.25 plus 0.25. So in each grid, when we change the unit into the kilometers, it's like 25 kilometers plus 25 kilometers. So it's the spatial scale is kind of fine resolution, because in general, for a global data set, the 25 kilometers is kind of a good resolution. Because for the climate models, in general, they provide the resolution at larger than 100 kilometers. So you can only use them for some large scale analysis. You cannot estimate for a given location. For example, here in Ravenna campus, if we use the output from the climate models, they cannot give you a very specific estimation, very correct estimation compared to the local climate. So there will be the bias. So the error 5, they provide 25 kilometers. So in general, it's useful and it's good enough for some, even for some local scale analysis. So here you can see the detailed description, the temporal coverage. So the data start from 1940 to present. And here the temporal resolution will be hourly. And the update frequency will be daily. So in each day, they will update 24 data. Like for each hour step, they will update data. And when you click here, the main variables, you will see all the variables they provided. So you can see the name of the variables and also the unit of the variables and also the description of all these variables. So in our lecture, we will be focused on the wind speed because we will do a case study on the Strait of Messina. So we only interested about the component of wind. And what we will use is not the 100 meters because the 100 meters is kind of higher than the bridge. So we will use the 10 meter, 10 meter component of wind. So I will explain later what does it mean, the U component of the wind and also the V component of the wind. Because the wind, imagine if the wind is not similar as different as other variables. For example, for precipitation and temperature, we only need to know like a number. So the number, they describe the magnitude of the precipitation and the temperature. Yeah, but for wind, we will have a direction. So in general, in all these data sets, they provide the U direction and the V direction of the wind. So the U component is the vector of the wind, and the V component is another vector of the wind. So in this variable, they not only provide the magnitude of the wind, but also the direction of the wind. And then we will calculate the wind speed, the exactly wind speed by using these two variables and the exactly wind direction. So this is the general introduction about the reanalysis. So if you click the download, so here we will be direct to the page of the download page. So here you can see, you can choose the reanalysis, the ensemble members, or the ensemble spread. So here, what does it mean in the ensemble? So the ensemble, it means, as I mentioned before, the Arrow 5 is a reanalysis dataset. So in their model, they provide lots of outputs. You can imagine they may provide 30 outputs. So for the 30 outputs, each one is a member. So if you select the ensemble members, you will have all the outputs for all the members. And if you select the ensemble spread, they will give you a range. So the highest one from all the members and the lowest one from all the members. So they will give you a range between the highest and the lowest. And what we are interested is the ensemble mean. So it's better to start with the ensemble mean because it will be a mean value from all the members. So it will be a time series or mean value at each grid. So you can forget about the members. So we will start with the mean. So here we can select the variable we interested. For example, the two components of the wind. For sure, if you are interested about temperature or the other variables, just click, and then you can download. So they also divided the variables into different domains. So you can, like, if you know the wind, so all the variables about the wind. So we select these two, like the 10 meter U component, or not this one, all right. Not the neutral wind, just the component of wind. So the natural wind is another variable. So be caution about this. So what we will use is the U component of wind. And the component of wind. So these two. And then here we can select a year. Like you can see, they updated until 2025. And the months we are interested. So you can see now we cannot select November and December for sure, because now it's October. So for example, we select October, and here we are. So in general, they updated until the 10th of October. So in the website, they wrote 5 days delay. So it's kind of 5 days delay. So now today is 16th. So you can download the most updated one to the 10th of October. Then you can select the, like in this hourly step. So we can just select all. It's easier. So then you can, yeah. So now we need to, if we want to download data from this website, we need to get an account. But it's open to all the users. You just need to register. I recommend you to register by using the Univo account. So you can register by using the Univo account, and then, for example, here I can log in with my account. I already have an account. So here Univo, Univo, right? Then we insert password, login. Sorry. Right. No, I cannot insert. Sorry. Maybe because now the language is English. Download. Example, components. Yes. English. Yeah. Here we are. Sorry, the keyboard is. I always forgot my password. Okay, let me try again. So, okay, anyway. So let's skip this now, because now I recommend you to register account, because now I forgot my password. I need to check it later. Okay. So here we will have a detailed documentation about the error file. So here you will find what is the reanalysis. So as I mentioned before, the reanalysis dataset, they combine the observation from the stations with the weather forecast through the data simulation, and then they will create a physical consistent grid record from the past to current. Like, for example, the error file, they provide from 1940 to current. And then they will update it within the updated observation and the weather forecast. So if you click the figure here, you will be directed into the official document of the description about the concept of the reanalysis. So for example, here I click here, and this one, I will be directed to the official description about what is reanalyzed. So they will give a more detailed description about this concept. So how it works, how can we access, and how can we use this dataset. So there will be a very detailed document and a very detailed document about the error file. So here I provide all the links where you can find the detailed description about the dataset. And then I will introduce you another tool in this web page. Example here you can see besides the climate data store, is the one we use to download the dataset. They also provide this climate service atlas. So we can click into the atlas. So here, when the first time you click into the atlas, they will give you in general the description about this web page. And then what we will see here, you can see a map here, right? The map is a global map. So there are a lot of different description about variables. For example, here the default map is about the mean of the daily temperature. From the climate models, is the relative change to the past 50 years. So this map shows this information. So how we can use this tool? So here I will start to teach you how to use this tool. Because by using this tool, we can do some very basic analysis without downloading the data. Because they provide the interface to visit the data directly by the climate data store. So for example, here, so in this part, we can select what data set we would like to use. So we can select the error file. So then the map change. So now they provide the temperature from error file directly. So by only one click. So it's very quick. And here, for example, they show the map about the temperature, but what we are interested in is about the wind, right? So they already provide the mean of the daily mean wind speed. So here we are. We will have a map about the wind speed here directly. And also here, for example, if you don't like the map view, you can change the projection of the map. So here, change the map projection. Did you see the option? Change the map projection. So they will provide they provide lot of different projection. For example, we select Robinson. So the map projection changes. So it's more straightforward, maybe. So there are a lot of different projections. So by only click, you can explore it by following the lecture. So when I introduce it, you can click on the website to see what's the change happens. So don't be afraid, just click. So it will not case any loss, right? So just click. And here we select this projection and we are interested about the climatology. What is climatology? So it will, for example, here we can select the temporal range of the dataset. We are interested about the past 30 years. So we select the past 30 years. And then we quantify the climatology. What is climatology? In general, they will give us a mean value of the wind speed of the past 30 years. We call it climatology. So it provides the mean state of the past climate. So the mean state of the past wind speed. So here we can see the climatology about global wind speed. over past 30 years, from 1991 to 2020. So here is the annual one. So it's about the annual mean. And what if we can also select for different seasons? If we want to see what's the climatology in winter, click the winter one. So it's changed, but not that big because it's due to the visualization of the color or due to the because it's the climatology, so it will not change that much. And here you can see the unit of the color of the wind speed. So it's meter per second, and the color represents the number. So the dark green represents about 8 meter per second. So here for sure you can change the color as you like. So I change into this one. So map changes. So this one. So just explore it. And it will change the also the magnitude, which represents the largest one. So now the largest one is 12. And also you can reset to default. So only by click. And now, for example, if we are only interested in this region, in this Mediterranean region, we can click this grid because here you can select. There are some different region derivation, for example, European countries. So they can select for different countries. And also there are some, so for this region, it's from the World Climate Organization, they divided the world into this kind of different regions. So in Europe, they divided into 3 regions. So this one, Mediterranean, and this one, Central Europe, and the upper one is the Northern Europe. So when we click for the Mediterranean, so we can see the regional information. So it will show regional information. We can click the regional information. What we got, we will get a time series. We will get a mean. So what this time series means is it's the mean value of all the regions for all the grids. So they will give you a time series of the daily mean wind speed from the 1940 to present. So it's more straightforward. So you will get a knowledge about what's the range of the wind speed for this region. So for example, here we can see in general, the 1941, it has a very large value, about 5 meters per second. So nowadays, the 2024 is much lower than that value, right? And here you can also see the annual circle. So what does this figure mean? It will give you an overview for every month. So it's the mean value for January, February until December. So they will give you a mean value for every month. And here we can also see so it's a different way to visualize the time series, but it actually has the same meaning for this one. It's just change the point into the colors. So the darker the number is larger. And also the seasonal strips, so it's the same. And here we will also have some summaries, so you can see some numbers. For example, here they will give you the median of the wind speed in this 70 years from 1950 to 2020. And also you can see from different periods and most recent one, so different number. And also the range, the 25% to 75%. So the range of the wind speed. So here we will have some general statistics, so general values. And also here is the monitoring. What is the monitoring? Very cool picture. they show every year. So the monthly value for every year. You can also you can see, for example, here we can show the sequence for 2020, and you can compare with the other all the other years. So very straightforward. So here is how to use this one. And now we can also do a very small, not test, but small explore. I would like, because maybe you came from different countries. So here we can define the regions by ourselves. For example, here we can you choose the user define. And then, for example, I came from China. Yeah, my hometown is around the middle part of China, this part. So we can click on the start drawing, like we can make this region by ourselves. We can make a small angle, small squid, and then we click on the create job. So it takes some time because they will do some calculation from the data set. So it's running, now it's running, right? Wait a few minutes, wait a few minutes. Okay, when it's okay, we can click on this eyes. Like on this side, show results. So here we are. You will have a time series of the region you select. So no coding, no downloading, just select the region and all is set up. You will have a time series by the select region. And now we can download the time series. Like you can download as a CSV. So I click. So it's in Excel. It's already it can be used for other analyze. So very easy. And also you can also download the figure directly. You can show the figure to the others like here. You can see the time series from my hometown. So it's very straightforward. And also you can see the scripts, the summary table. So the sum. So in my hometown, the so in the because I select area in the land, in the middle of the land, so the wind speed is much lower than the Mediterranean region because in the Mediterranean region there are some parts on the sea, so the regional average will be higher. So we can explain the result by ourselves. So now I will give you a few times just to like you can select the region, like not specifically your hometown, but roughly nearby your hometown, and you can like uh, submit the tasks and then to see if you can get the time series in your hometown. So just a small explore. So to see if you understand how to use this page. Okay, you can start maybe. Yeah. If you need any help, or you need any problem, just let me know. And you can interrupt me. Yeah, anytime when you have some doubts. So for the students online, maybe after you get the result, you can share your screen. I don't know if you have the right to share the screen. Yeah, but first I encourage you to have a explore for sure. Yeah, it's a very powerful tool for the beginner because you can gain some basic knowledge about what happened and what the variable looks like. Yeah. Yeah. When you are trying, you can also repeat it if you need. Yeah. So here we can select the data set, So we select the error file. Click the error file. And here we interested in wind speed. So we find wind and radiation. We select the mean of the daily mean wind speed. And here we interested in the climatology. And we select the time for the past 30 years. And we select here the climatology. And then you can choose annual or any season you want. So for different season or annual. And here in this part, we select user define. We can define our region, and then click on this pencil, so we can start drawing. For example, in Iran, maybe here, right? In this part. No, Iran. 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 Yeah. Right. The right hand. Yeah. So this part is Iraq. Iraq. Yeah. So here, right? So this part. That part. Yeah. So in general, in this part, because in this map they didn't show the boundary of all the countries. So, but you are more familiar than me, your home country, so you will know where it is. So draw a small grid, right? Small angles, okay. Yeah. Then we can create a job. So every time you submit a job, it takes some time because it takes some time in the system, they receive your task. So it will show pending. And after they receive, it will run. So after the running, will show the result. So here we are. So here we see the time series in some regions in Iran. So the wind speed is also higher than my hometown. So yeah, it's straightforward. So you already succeed. Okay, very nice. So Fernando and Radha. So do you have any problems in explore the website?
Mine is running now. It says it's okay.
Okay, very good. So when it's running, just wait a few seconds, and then after it shows okay, we can got the result. So what about you, Radha?
I'm also doing.
Sorry?
It is running.
Okay.
Prof, after having the jobs, have okay, job
Okay.
16, da, 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 da.
Now
After I have 4 options, that is C jobs,
yeah.
then
Do you see the signal? It looks like eyes.
no, I don't see that. I
Oh,
only see
so
that small rectangular that was saying jobs, 2 dots, like this, only like this. After this, what
you don't
show
have this
results?
one. So this one looks like
Okay, okay, I
then
got
you
it.
can click it, right?
Yes.
Perfect. So you
Thank you.
can see the time series from your hometown, right? So it's very interesting. And for sure, if we are interested about all the different variables, just change the variables here. You can explore it later after the lecture. For example, we want to see the temperature, just select the temperature. And we do the same process. Then they will give you a result about the temperature and precipitation and all the variables here. So you can explore it as much as you want. And also, other than the error files, For example, here we will have an observation data set, but this one only cover, but for this one, it only cover the European domain because it's called the European observation. So it only cover these countries. And here we also have some climate models. So the CMAP6. Have you ever heard about these models? So it's the most updated climate models. So here we can also have the projection in the future. So let me show you. For example, here we select the CMAP6 and the same, the wind speed. And then we choose a scenario, a future scenario. So all the SSP represent the future scenario. We can also select the climatology and also the, yeah, but why they provide the error? Change. So yeah, there are different way to visualize the data. So for example, here we can quantify the changes. Let me see what will happen. So if we select the region, so here, Mediterranean. So here we are, you can see the time series. So the time series here is the result from the climate models. So for the climate models, because they start their historical period from 1850 until the end of this century. So in general, you will have a time series for this kind of more than 200 years. And each line, it represents a single model. So if you put your mouse here, you can see the name of that model. So for example, here is just the CMCC. It's an institution from Italy. So it's the model provided by Italy, by this institution. So this result, this slide, represents the model output from this model. And the other lines represent from different model institution. So for example, this one is from China, and this one from Japan, this one from Germany. So different institution. So you will see different time series, but in general, it's not that straightforward in this figure. They will give you a mean, a mean time series. For example, did you see the dark red line in here? So maybe it's easier to see in your laptop. So they will calculate a mean value from all these models. So this one exactly, the median. And here you can also show a single model. You can select here. So it's straightforward. Then you put the mouse. For example, here I want CMCC. So we are looking for CMCC. Here, so here's CMCC. So we click. So they will give us the model, the result. So they will highlight the result from this model. And then the same, we will have the annual circle from different months. So each line represents a different model. And the seek line is the mean value from all the models. And the script. So here I think each column, each row represents a model, or each column, I think column. And the seasonal tree strips, so the same as what we did, and also they will give us the statistic, the number. But you should caution with here, because now the number here is not the climatology, it's the change. So it's the change from this period, from 2040 to 2060. minus is 50 years. So it's the change in the future compared to the past. So this minus negative 0.1 means in the future, the mean during this period, the wind speed is 0.1 less than in the past 50 years. So be careful when you explain the result. But in general, the title of the figure, they will tell you what the number are. And also here you can see the term, the time period. So this number, you can see from 2021 to 2040 is minus 0.1. But when we look into medium term, so from 2041 to 2060, it's minus 0.2. And what about the last 30 years? It's from 2081 to like 2100. It's minus 0.3. So for each period, the mean wind speed are different compared to the past. So in general, so here in this atlas, you can explore the different climate scenarios from the climate models and from the observations and also from the reanalysis at a global, local, or different scales. So it will give you a like very straight way to do some analysis. For example, if you are interested to doing some analysis about the Strait of Messina, you can also select the region in the Strait of Messina. So here, for example, we can define our region here, right? The Strait of Messina. We can draw an angle here, like this, like what we did before. So we draw angle here, then create a job. Then we will get a result around the Strait of Messina. So I think it's a very useful way for beginners to explore this open access data set and doing some basic analysis. But you may find some limitation here. For example, our analyses are limited by their options. So we cannot do any other analysis. For example, we cannot doing some daily analysis or analysis. What we got an error. So we see let me change maybe. So climatology here. Delete 35. So we can only do the analysis based on this option. We cannot do some other analysis. For example, we cannot plot the distribution. We cannot do some deeper analysis for example, estimate the return period for a given wind speed. Such this kind of analysis. So they are useful because they give us a very general overview of what the time series looks like. And you can also, so sometimes we will face the error, but it doesn't show the error, the detail. You can see it. Seems that maybe I refresh the page. launch. So we look into the first file. Okay, let us see. So I think in the later classes, I will teach you how to download the data to our workspace and doing some other analysis, which cannot be done here. So, but anyway, as I mentioned, this tool is very, in my opinion, is very powerful. So here now we get the time series in Messina. So in the Messina, Strait of Messina, so we can have a time series around this region. So because also it provides the data set from climate models. Then I think everyone is already know how to use this tool, right? Radha, did you succeed in running the process?
Yes, Professor.
Okay, very nice. So we move forward. So before the lecture, so I think here I can give you a very brief description of the Google Colab. So the material I prepared is in the Google Colab. It's called Google Colab Notebook. And what is it? It's a free cloud-based Jupyter notebooks. So do you know Jupyter notebooks? So it's a type of tools we use to run in the Python codes. So what is this Colab? It's provided by Google Cloud. So it's kind of a Jupyter notebooks in the cloud. So why we use this one? You don't need to set up the Python environment in your local machine. You don't need. You can just open this Colab notebooks. So you can visit the web page. And in the web page, if you have the Google account, I think everyone has the Google account, log in into the Google account, and then you can run this codes, run this Python codes directly. So you don't need to do any other setup because it's always hard to set the coding environment. But if we have this kind of Colab, we don't need to set up. So it's a very powerful tool. So I close all this one. So here is the name of the notebook. So it's the name of our course. I recommend you after you open the notebook, you can click the file here. You can make a local copy. You can save a copy in your drives, in your Google Drives. Because here I think you cannot modify these notebooks, right? Can you modify this Colab? Have you tried? No, you can have a try. Because I think you cannot modify here directly because I share with you, you can only read it. But I can modify here directly. If you want to modify, for example, here after you open, you can save a copy in your drive. And then open that copy, you can modify that copy. So you can modify every code I write for your analyze directly. So you don't need to write all this document. You can modify based on my notebooks. So, and also you can take notes while following the lectures. So I recommend you to save a copy and then open that copy in your laptop. So now you can do it to see if it works. Yeah. And also the Google, they provide some GPU and TPU resources. So we can do some machine learning stuff, but it's not the aim of these courses, just to introduce the advantages of the collabs. And also you can load the data or load the files directly from your Google Drives. So it has the interconnection within the Google Colab and the Google Drive. And for sure, it's easier for collaboration and sharing. You can, yeah, I think it's easier for sharing. That's why I choose this way, because I can prepare all my codes and documents, then share with you. You can see the codes, you can run the codes, you can click all the links, and you can modify the codes in your own copy and doing your own analysis. So it's very powerful tool, I think. And here we can install the packages as the same as other Python environment. We can install all the Python packages we need. And in general, it's easier than your local machine because the Python libraries in general, there are some conflicts. So sometimes it's very hard to manage all the packages. But in Colab, you can imagine each Colab notebook as a individual project. So, for example, in this Colab, I can only install the packages I need in this notebook. So it will not influence the other notebook I have. So it will like it's a separate one. It will not influence my environment. And it's very reproducible. So it's very important for teaching and also in doing research. You need to let the others know how to reproduce your results. So for example, here, if you have my notebook, you can exactly get the same result as I show you here. So by running all the codes. So here, so you finish, you save a copy into your local drive. Yeah, so now you can try to modify it to see if you can. I think you can after you save into your local copy. Like you can insert here, for example, when you put the mouse here to show two options. One is code. Like you can create a cell for writing the code. And one is text. Is the one you can write the notes. Like here, note for the lecture. You can take the notes while you are following the lecture. Notes for the lecture. For example, here and then close. It will show here. That works. Okay. Yeah, and you are very free to modify your copy because it will not influence this original one. So don't be afraid that you destroy this one or make any mistakes. You can always save a new copy from the original. So just go ahead, explore the notebook, that like text your note, and you can even insert a code to see what happens. So don't be afraid, okay? So you have the, because you already have the link in the website of Professor Montanari, so every time you can save the original copy from that link. So that's it. That's the general introduction about the Colab. Do you have any question from online? Because I need to hear your feedback. Did you succeed in save the copy of the notebook?
Yes, Professor.
And are you able to modify it?
I haven't tried that.
Yeah, okay. Nice. You can take notes on that.
Okay.
Yeah. That's okay. So what about you, Fernando?
To take notes on that, I just need to go to plus text, add text.
Okay. Yeah. You can, for example, if you want to take the notes, you can click on here. you can, after the cells, you can click on add a text cell. So once you add a text, and then you hear, it's the same as the word. You can consider it like a word. You can type here,
Oh,
like this.
okay.
And when it's closed, it will save automatically, like here. You can also change the plot, like this, and make it so anything you want. Also here you can
Okay.
insert the links and the images, anything. So you can consider it like a small version of the Word, but inside the notebook.
Okay, thank you.
Yeah,
Able
yeah.
to do it.
Okay. After we finish this, so we came to the last part in in uh, in this morning lectures. So now we are going to register in the climate data store. It's very important because if we want to download the data from that data store, we need an account. So we need to go to register. So we go back to the data store. And here you see login or register, right? In the right up button, we click on register. So here you will find the register new user, right? Register new user. We click register new user, and we can insert our name, first name, last name, and the email. I recommend you to use the Univo email. And then you will insert your password and then confirm the password. After you finish all of this, just click on the register. Let me know when you are ready or if you face some problem.
Sorry, Professor, I had already login before, but now I am not able to do it again. I don't know why. I have registered it before.
So you already log in. You already have
Uh,
an account.
yes.
So it's okay. It's okay. Just if you already have an account, it's okay. Just keep it logging. So now, so in your part, you will find your username here, right?
Yes, but now I'm not able to log in again because I don't know why.
Ah, really? So when you click here, you cannot log in with your username and password.
Um,
Okay. Did you insert the correct email and the password? What it shows after you click login?
it is going like this. Okay, I will send you the snap.
Okay, yeah. Yeah, don't worry. Yeah, yeah, we have time. Yeah. For example, here, maybe I can show you. I can use my other email to see if it works. For example, here I type my name, Ray, and the email. I use my Google email. It's not registered. I insert my password, confirm my password, and so I cannot use that. Okay. Then Now, after I insert all this information, I click on register. They don't allow me to register by this Google account. That's why I recommend you to using a professional one. Let me try another. Register. Okay, so this one is okay. Maybe you didn't verify your email because they will send you a link into your email address, and then after you click that link, you can log in, I think. You already succeed. Okay, good. Radha, did you hear me? Did you hear me?
Yes, now I am able to log in it.
Okay.
I had to change the password.
Okay, very good. What about you, Fernando? Did you finish the register? So let me check.
Can you hear me, Professor?
Yeah, now I can. Did you finish the register?
Yes, I'm about to. It's just for affiliation, we should choose research and education organization.
Yeah, you can choose education. Yeah, I think it's okay.
Research and education
Yeah,
organization.
yeah. Because we are in the university. You already logged in. Yeah, very good. Yeah, that's okay. Yeah, because we need to log in, then we can download the data. So
Okay, got it. I logged
okay,
in.
okay. So after we log in, right, we will have a page like this. We will have our username in the right. So did you see the profile web page? Are you direct to the profile web page? So here we will find the one we will need. So we need to, here we insert something like Italy. This one, maybe. Organization. No, it's okay. Every country is okay, I think. But if we use our Unigo account, we can use this one. Activity is like research.
On top, there is climate change. Okay, so we should change to research innovation. Okay.
Sector, research and education. Yeah, it's okay if you choose climate. It's okay. They just ask us to check, ask us to select. Then we agree the terms and conditions. So we agree. And then we click the activate. We should activate. So it's successful activate, I think. We will go into our profile. We click the name of and select the profile. So here, the change. Now it shows the API key, right? This is very important for us because this is what we will use to download the data by using the Python code. So we will get the access to download the data through the web, through the data store. You can consider this key like a password. So we use our account and this password to download from this data store. So I think very good. Did you succeed in activate the accounts? Radha and Fernando, did you can you see your API key here?
Yes.
Okay, okay, perfect. So we succeed. Also you, okay, very nice. What about you, Radha?
Actually, I had the project with the CMCC, so this account has already been logged in.
So you already have this one, right?
Yes.
Okay, okay, that's good. Yeah, we only need this one because we teach us for register because not everyone has a account. So if you have, you can use it directly. So very good. Now everyone has the API key, and then in the lecture in the afternoon, I will show you how to use the codes to download the data from this Limex data store by using our API key and doing our own analysis. So do you have any questions about the morning lectures? So Bernardo and Radhe, if do you have any like questions or anything need me to explain? You can ask now or later.
No,
I
Professor.
think it's clear.
Okay. So now maybe we can stop the lecture now, and then we will see you later at 2 p.m. Right? Okay. I think it's time we can go to have a lunch or take a break. Thank you very much. And in the afternoon, we will use the same link as so use this one. Okay?
Professor, thank you.
Okay, no problem. So I will stop the call. Stop recording. Stop recording.